Hey, geometry students. This is Mrs. Green again. I hope you had a great weekend, a long weekend. I wish the weather was warmer, but what do you do, right? So I hope you're all doing well. My family is actually doing pretty good. Our dogs are loving it, as I think most pets, with having everyone home. But I hope you're all doing well. Send me any messages or emails if you need anything, okay? All right. So if you have not completed this warm up by yourself yet, I need you to push pause on this video and I need you to do the warm up on your own like you would at the start of class. And then we always come back and check it together in class. So please do it first to kind of see where you are and what you need. Okay. All right. So last week we talked about mutually exclusive and overlapping. You're not going to learn anything new this week. All you're going to do for these 4 days is just review the compound, which is mutually exclusive and overlapping. Okay, so number one, let's check your answers. If you are going to roll a die and the first event is the number has to be greater than 3, so that would be 4, 5, 6, and then the number is even 2, 4, 6, you heard that there was overlap. So therefore, this is considered an overlapping. So I'm just going to abbreviate and put OV, overlapping. Number two, if the first event, if you are going to maybe pick a student out of Lakota West, and the first pick, we would see, okay, what's the chances of getting a person that's a junior or senior, I'm sorry, and the second event is a junior. At least the way that we label things in school, you can't be labeled as a senior and a junior at the same time. So those are what we call mutually, I'm going to abbreviate again, exclusive. Number three, the chances that you pick the correct answer, and then the second event would be the answer is A. Well, since the correct answer could be A, B, C, D, and then the second event is the answer is A, you heard that there was an overlap there. So this is overlap. And the last one, number four, the experiment is selecting a chocolate bar, like a chocolate candy bar. So what would be the chances that the first event is that the bar has nuts and the second event would that the bar has caramel? Well, one candy bar that I think of is Snickers. I'm not really a fan, but my family is. A Snickers has nuts and caramel. So that's definitely what we call overlapping. Okay. So I hope this warm up gives you a chance as you continue on through the next set of questions that I'll check with you is helping you understand the differences. Okay. All right. Number five. Remember, there are 52 cards in a deck. So we're going to be talking about what is the probability that you are going to get a jack or a spade. Now, if we think about this for a minute and you think about the lines of is this mutually exclusive or is this overlapping, this would be definitely overlapping because a card can have a jack on it, and obviously we have the jack of spades, so it can have both at the same time. So this is definitely overlapping. So what we're going to do is mathematically, we're going to find the probability that you pick a card and that it's a jack. We're going to find the probability that you pick a card and it is a spade. So right now, you would have 4 out of the deck, out of the 52, are jacks, okay? And there are 13 cards in the deck that have, 13 out of 52. So we would add those together. However, we know that out of the 4 jacks, one of them is also a spade. So this is where we need to subtract away what we call the overlap. So I'm going to put the probability of both, meaning it's a jack and a spade. And there's only one in the deck. Okay? So if we do our adding and subtracting, they all have a common denominator, so we can just add and subtract the top. So 4 plus 13 is 17 minus 1, so you're going to get 16 out of 52, but that reduces to 4 out of 13. So your answer is 4/13. All right.
Okay, so in 6, 7, and 8, we have the same chart that you've used a number of times in this chapter for probability. And the first question is talking about what are the chances of getting the probability of doubles and the probability of a sum of 4. Sorry, y'all, it's hard to write. So if we take a look at our doubles, what that means is you roll a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, a 5 and a 5, and a 6 and a 6. So that would be 6 out of 36 numbers that you see in this entire chart. Okay? Now, the probability of rolling a sum of 4, so out of the 36 spots that you see in our table, we're looking for a 4. So we have 1, 2, 3 right there. Okay? So if I go back and I look at our doubles, so the 4s were our doubles. And then in a different color, I'm going to highlight when we rolled a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, a 5 and a 5, and a 6 and a 6. As you can kind of see from my illustration, there is one of the boxes that has green and red in it right here. So that's called our overlap. So we have to subtract away the probability of getting a doubles and a sum of 4. So it's kind of like in our Venn diagram, it's the overlap of the circles. So we want to subtract away the 1 out of 36 in the entire chart. Okay? So once again, the denominators are out of 36. So once you have a common denominator, we can then add and subtract. So 6 plus 3 is 9, and 9 minus 1 is 8. So when you reduce 8 out of 36, our final answer here would be 2 ninths. Okay? All right, so let's go to number 7. So we still have the probability of getting doubles. Now we can use our answer from up above, and that was 6 out of 36 of getting chances of getting rolling a double. I should say rolling. I'm going to get rid of this so y'all can kind of see what's going on. And then we want the probability of a 7. So before I go to a different color here, once again, here was the doubles. And then in green, the sum of 7s kind of go on that diagonal. So we got an X going on. And we have, and so we do not have any overlap. So what happens is when I am going to go back and add the probability of the sum of 7, and then we would subtract the probability of the overlap, or what I call of getting both a double and a sum of 7. So as you can see in green, we have 1, 2, 3, 4, 5, 6 spots out of 36 that have a 7 in the box. But there's no overlap. Now, yeah, these X's cross, but they don't cross on a number. So there are 0, or you can, I'm going to write it as a fraction just so you can kind of get an idea, but it's just 0. So 3 out of 36 plus 6 out of 36 minus nothing is 12 out of 36, and that reduces to 1/3. Okay? All right, and finally, if this confused you as you were doing the warm-up, I'll kind of walk you through this now. As I'm talking, I'm going to erase above so it doesn't get confusing. But for number 8, we're looking at the probability that our first die is a 5. So the probability that you get a 5 on the first die, and the probability that you get a 5 on the second die. So if we look up here at our chart, if you roll a 5, so let's think about here. If you roll a 5, there are 1, 2, 3, 4, 5, 6 out of 36 options of rolling a 5. Okay? Now this next one, the probability of rolling a 5 on the other die, well, that would be right here. So that's 1, 2, 3, 4, 5, 6 again. So that would be plus 6 out of 36. But you'll notice as you see this chart, we have overlap. So we want to subtract away the probability that both die are 5s. And that happened this one time right there where I'm showing you that overlap. That would be minus 1 out of 36. So if you add your numerators, which is the top of your fractions, 6 plus 6 is 12, minus 1 is 11. And that does not reduce, so that is your final answer. All right, the back side of your warm-up, just a couple more questions. And I put this on there because I think some of you are still struggling with the Venn diagrams, so I just want to make sure maybe me kind of voicing over this warm-up will help. So for the first one, we are asked to complete the Venn diagram, and this is about cupcakes. So there are 27 cupcakes total, and there are 13 that have icing, 11 have sprinkles, and 4 have both. So I think it's kind of nice to go ahead and put the 4 in our overlap. So there's our 4. Now keep in mind, when it says 13 have icing, we cannot just slap a 13 right here. That's not correct, okay? Because in the circle, 13 plus 4, that now gives you 17, and that's too many with icing. So 13 minus 4, if I think that through, that's going to give me 9 that only have icing. 4 have icing, but also something else. So that 9 plus 4 is 13. And then we'll do the same thing for the other side. If 11 have sprinkles, then I need to do 11 minus 4, and that's how we would get 7. Now, if you can see in this circle right here, 7 plus 4 is 11 have sprinkles. And then if you add the 9, the 4, and the 7, that's going to give us 9, 10, 11, 12, 13. That's going to give us 20. And then since there were 27 total cupcakes, that's how we kind of get what's left outside. So obviously some are plain, and some people like just the plain old cake by itself with nothing on top, okay? So number 9, we can mark off our list. There is your Venn diagram. For number 10, the probability that we have icing on the cupcake. Well, out of the 27 cupcakes, there are 13 of them that for sure have icing. So we would include the 9 that just have icing alone and the 4 that have icing and sprinkles. So that's 13 out of 27. That does not reduce, so that's official. For number 11, the probability that you pick a cupcake with sprinkles. Well, there are 11 out of the 27 that have sprinkles. So that's official. So that's done. Numbers 12 and 13, I'm going to move this up together and I'll scroll back down if I need more Venn diagram. I think I have those numbers memorized. But on number 12, it's asking you for the probability of picking a cupcake that has icing or sprinkles. Now this symbol right here, if you can remember, I'm going to pull my little Venn diagram down. This symbol means or. So we're talking about it can have icing or. So that means we want to include all the icings, which I guess would be, icing by itself would be 9 of them. 4 of them have icing and sprinkles, and 7 just has sprinkles. So if we add those up, we get 20. So 20 out of 27 would be our final answer. So really the only thing we can't include are the 7 that don't have anything on them, okay? And then the last example, question was number 13. This is, this symbol right here means and. So you have to find the probability of picking a cupcake out of the 27 total cupcakes. How many of them have icing and sprinkles? Well, that's going to be, if I pull this back down, that's going to be this inner layer right here. That's going to be the overlap. So we're going to have a probability of 4 out of 27. And none of those reduce. So there you go. I hope that helps.